Here's another example. Now we've got a fourth degree equation, x to the fourth. So when we're looking to find all zeros of this polynomial, we know we have this many zeros, our highest degree, so we'll have 4 zeros. All right? So again, we'll check for our rational roots. Hopefully we'll have a rational root or two, so we'll be able to reduce this down to a quadratic, and then we can use one of our quadratic methods to solve it. So we know our possible rational roots will be factors of 15 over factors of 1. So that's just going to be plus or minus 1, plus or minus 3, plus or minus 5, or plus or minus 15. Those are the factors of 15 all over the factors of 1, which are just plus or minus 1. So that's all we've got. So those are our possibilities, those 8 possibilities. And we'll just check those in. So we'll divide those out. So I'll start with 1. That's always a good place to start. Now remember, we're missing a cube term, so we need to put a placeholder here. So we've got 1 for x to the fourth, 0 for x cubed, negative 2 for x squared, negative 16, and negative 15. Yep, spread those out a little bit too much. Okay, so I have to kind of squinch these in over here a little bit. So we'll bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus 16 is negative 17. And 1 times negative 17 is just that, and that's going to be negative 32, so that's not going to work. Okay, so I can cross that out. Let's try negative 1. And I'll use the same numbers. I'll just squinch them in a little bit here. 0, negative 2, negative 16, and negative 15. Oops, sorry about that. 5, there we go. And we'll bring down our 1. Negative 1 times 1 is negative 1. That's going to be 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 2 makes that negative 1. Negative 1 times negative 1 is positive 1. Negative 16 plus 1 is negative 15. And negative 1 times negative 15 is positive 15. And there we go. We got our 0. So that means negative 1 is one of our roots. Now again, it could be a repeated root. This is not a root. It's not a possibility, but negative 1 could go in there again. But we'll just try. We'll just try our next possibility. So now we've got this. Now we've got a reduced equation. Now remember, this is like we started x to the fourth. So since we divided out one root, we now have this is 1x to the third minus 1x squared minus x minus 15 equals 0. That's our reduced equation. It's a cubic. We started with the fourth. So now we want to check the roots here. And it's going to be these same possibilities. Sometimes you can reduce this, but this is going to be the same, so it's not changing. So we'll just go with our next possibility, which was 3. So let's divide 3, but now we're going to divide 3 into this cubic. And hopefully that will yield something that'll work. So we'll put 3 over here. And I'm using now these numbers because I've reduced it. I could do it again with these numbers, but it's going to be a little shorter to do these numbers. It's also going to lead to my reduced quadratic at the end. So again, we're trying to find our zeros, so these are our possible rational roots. And we're going to try 3, and we're going to use these numbers now because we reduced this. So that's going to be 1, negative 1, negative 1, and negative 15. And again, this reducing form is going to leave us with a quadratic, hopefully, that we'll be able to solve. So bring down our 1, and 3 times 1 is 3. That's going to be 2. 3 times 2 is 6. That's going to be 5. 3 times 5 is 15, and there we go. We got our other 0, because negative 15 plus 15 is 0. So there's our second root, and it's a rational root. So we got a couple of roots so far. Now this is my reduced equation. This is why I wanted to use this process, because now I've got 1x squared plus 2x plus 5 and equals 0. So that's what my reduced equation. So we started with a fourth degree equation. Once we divided out a negative 1, we found a root there. We have a third degree equation. And once we got a 3, which are one of our other possibilities, we divided that out and we got a second degree equation. And now we know how to solve these. There's lots of ways to solve these. And this is a good candidate for completing the square because this is 1 and this is even, so we'll do completing the square. So what I'll do is I'll say x squared. I can also use the quadratic. Sometimes you can factor. Plus 2x, and I'll subtract 5, so I got negative 5. And then the square root of x squared is x, and half of 2 is 1, so I'm going to add 1 squared to both sides. And now this is going to factor to be a nice binomial squared. There's my sign plus 1, and there's my x and 1. And negative 5 plus 1 is negative 4. So if x plus 1 squared equals negative 4, x plus 1 equals plus or minus the square root of negative 4. That's the same thing as plus or minus, and we have a negative, so that's I, so 2i. And then if I subtract 1 from both sides, x equals negative 1 plus or minus 2i. So those are my other two roots. And we had 4 roots. So either x equals negative 1 plus 2i, or x equals negative 1 minus 2i. So those are two of my roots, and my other two roots were 3 and up here was 3 and negative 1. So I can write negative 1, 3, and I can write negative 1 plus 2i and negative 1 minus 2i, and those are your 4 roots. And 2 roots are what we call imaginary. Well, they're complex imaginary numbers because they're complex numbers, but they have an imaginary part, and they're in conjugates. In other words, we have plus and minus in between. So these are what we call conjugates, and our complex imaginary roots always occur in conjugates. So those are your 4 roots. All right. So again, I hope you understand the process. It's not too hard. You just have to be patient with the synthetic division and be careful that you don't make any errors, and everything should work out. So hopefully that will work out for you.